Alright guys, so now let's start seeing how we can get the network connected to the fish. And as you can see, we are moving along nicely with the time. I apologize for these long videos. Again, code along, not a tutorial. If you guys want a tutorial, I would love to make one. But I need to get some views on this to show that there's like a tutorial will even though it doesn't look like it, a tutorial takes a lot more effort than me just coding and trying to put this together. It's a lot easier for me to just code usually. Okay, so now that we're done with the network, we're moving in to connecting the network to the fish controller. For that, let's pull up Visual Studio Code, and we left off right here, right? We're going to now move to the fish controller and get ready for the fish controller to pull in the network. Okay, so right here up on top, we're going to create a public neat network variable. Sorry about that. So we're going to create a public neat network variable, and we're going to call it my network, because this is the individual network for each fish. So when we spawn 20 fish, 20 fishes will have their individual networks. And usually fishes will actually have genome, and the genome gets passed to the network. But for testing purposes right now, just to see if our network is feeding values forward properly, and to see some movement finally in the fish has just been sitting there. We're going to manually create a network by defining the genome, right? And then we're going to see how the feed forward value is working in the fixed update. So we have my network here, and then in the awake function, we're going to let me get my code up 1 second. All right. So then in the awake function, actually none of this this part isn't even in my reference code, because I'm just trying to see if the network is working. So we're going to just have to figure out how we're going to implement this real quick, just to see how it works. All right. So in the awake function, I'm thinking I'm going to initialize my network. Okay, wait. So to initialize the network, however, I need a value for input and output. So I'm going to comment this line out for now, and I'm going to create public int input nodes, output nodes, hidden nodes. Okay. And so that will tell us how many input nodes, output nodes, and hidden nodes we want to have. And so then we can come back to this line right here, uncommented. And then, to comment this control, and the question mark key. So press those two together and a comment line. Alright, so my network, my equals needs network. And we initialize that with the input nodes. Let me make sure how it looks. So we want to make sure we line up the input nodes, output nodes, and hidden nodes. So when we look at the constructor right here, we take input, output, then hidden. Input node, output nodes, hidden nodes. And then that creates our initial network. The initial network with these input nodes, output nodes, and hidden nodes creates a genome, and creates the genome and creates the network structure. Okay, so we call the neat network constructor that calls this code right here, which creates the genome, then creates the empty list and then populates those lists with the create network function. All right. So all up to here, everything has been used, and then in the update function, we call this feed forward right here. So in fish controller, we'll go back to fish controller, and this is where the magic and the movement happens. We go my network dot feed forward network, and we pass it we do not have sensors for our fish. Let's create the sensors. So we're going to pass it the sensor information, right? But we don't have sensor information yet. We will get the sensor information, but just so you know, the feed forward part goes right here. We're going to comment that out for now. So let's move up over here and add the sensor information part. So right up underneath the range that we have, actually we'll keep that at the bottom. Right underneath input nodes and output nodes, we want to create the a array of floats. And we'll call this sensors. Right? And we have to initialize these sensors as well. Let me make sure I am doing this right. Alright. So we have public float sensors, and then in the awake, we want to initialize those sensors to whatever value is set for our input nodes. So awake, we want, it's fine wherever we do it, right? Sensors equals new float, and then we're going to make that of length input nodes. And that should be good right there. So if we put 3, this will be 0, 1, 2. Three values. Alright, so now that we have sensors, we need to actually get that information. Okay, what does our sensors actually going to get? It's going to be raycast. Alright, and this is the interesting part of the Unity, well, specifically the Unity part of the tutorial, where we set up the raycast for the input sensors. Okay, so right here we do private void input sensors, because that is the function we're going to be using to populate the input sensors. And since our input sensors are accessible, we don't need to return or do any of that. So over here, we are just going to leave it like that. Okay, so for the raycast, right, we are going to be, I have to see exactly how we're going to be doing this. So I have a couple of different ways that I do this raycast. Specifically, in the future, I want these sensors, these eyes of the fish, to be able to move. So that involves getting an angle from the fish and making sure getting the angle in degrees of how the sensor is pointing out of the fish, and then slowly changing that, right? But to do that right now would be a little ridiculous, because we don't even have the genetic manager set up. So just to see if our network is working, we're going to do this without any of that. And I believe the way to do it here, let's see, because I don't have reference code for this, and I should have prepared better, I guess, but I think we're going to be okay. It shouldn't be too bad to figure this out. We have the array, and we're going to give it the direction we want it to go. So we start the array from transform the position, and we want it to go in the transform the forward direction. Okay, let me see if this is working properly, and if not, we're going to have to Google a little bit. Nice, looks good. but we can't actually see if it's working or not without visualizing the ray. We don't have any errors, which is always nice, but let's try to actually see the ray. We have to get the hit point from the raycast, and now we do the if statement. If physics dot raycast r dot out hit ray distance, then we do an if hit dot transform dot tag equals wall, because our wall should be tagged with the wall. And for right now, I'm just going to create 3 sensors that sees walls, and I wanted to draw a white line if it does see a wall, and store sensor information. Alright, so this is our first sensor, and this is our first raycast, and that will match to our first sensor. Let me change the physics right there so it's nice. So we're going to store it in our 0th index. So we're going to do hit the distance, because we passed the value of hit back out to the distance, to right here. And so we got it right there. Hit dot distance divided by I want to have a division value here so that we can have some more control over our array, how far it goes. So for right now, I'm just gonna close that line. I'm going to scroll up to create another float, and this will be underneath the sensors and all this. It's going to be float. I'm going to call this private float. This should also be private. Sorry about that. Private float sensors. And then private float. This is going to be hit distance. Hit divider. And we'll set that in our editor. I think actually we'll give it a... Oh god. What did I mess up? Whatever. We'll give it a 20 value of 20F for now, and then we'll see. So we have the hit divider right here. Let's scroll back down. So right here where we left off at line well, I don't know what line you guys would be on, but right here we left off, and we're going to divide this by the hit divider. Okay, so that gives us some more control of how far that ray will be shot. So now that we have the ray going out, we then need to draw the line, right? And to do that, we do a debug dot draw something. Hold up, let me look to make sure. Okay. So to draw the line for the raycast, we do debug dot draw line r dot origin, and then hit dot point, and then color dot white. So color is the unity color, and that should give us white. Hopefully we'll see how that works right now. We'll save that. Input sensors is going to be called in the update function as well. In the fixed update that we have, we call that before we call anything. So we get our input sensors, and then we get our information for our input sensors. So the sensor has now been filled with information, and then we feed that information forward to the network. So starting off, we are going to have 3 inputs just to see if we have 3 lines, right? Well, yeah, so we're going to copy this over 3 times, and And then we're actually just going to copy up till here, right here. So we're going to copy and paste that right there. And then right above that, we're going to do r dot distance. So we're going to change the distance equals transform dot forward plus transform dot right. Let's see if that works, or if that throws us errors. Yep. Debug lines at the closing. Sorry, sometimes I forget to close because I've switched between Python and this. Okay, so we have to have a value that corresponds to inputs. Ray distance right here, we have to define the ray distance. Sorry, I'm so used to just having that set up. So right here where it says ray distance, that actually needs to be a float as well. But we define that we're going to define that float in the editor as a public value, so we can define how far the distance travels, the ray travels. The division hit divider is actually to regulate the values that we get from the hit. So right here, this is going to be all of our ray stuff. So we're going to do another private float, and we're going to do ray distance, and we're going to equal that to 40f. Alright, so that should take care of that error. Alright, let's go back to the ray right here. Okay, so the ray distance has been put in, so that solved our error for the ray distance. So right here where we say ray distance, this gives us the how far the ray will go. Right here divides the value of the distance so that we have our value our value doesn't get too large. Okay, and then this draws our ray. Over here we get another error, r.distance, because ray does not have a distance. This should actually be direction. Okay, transformed forward, transformed right. So now that the direction is there, we still have one more error. But let's see what's going on. Okay. There is no argument given to corresponding to the required form parameter inputs of neat network. So we have to pass it. Right here we have feed forward network. We have to pass it these sensors. And that should be good. So we pass it sensors. It gives us the feed forward network, returns us the outputs, right? So our outputs, so we have sensors, and then we have private float outputs. Actually, we won't have a private float up on top over here. We will just add the outputs. So I just backspace that out. We'll add the outputs in the fixed update. So we'll create a new float outputs equals, yeah, just do new floats outputs, and then we do outputs equals the my feed forward network. And I guess we don't even have to do that. Right here we could just write float, and that should do it. And now that we have our outputs, when we do move fish right here, instead of passing in acceleration in t, which was given from the sliders, we can just pass it the outputs we got. We do outputs 0 and outputs 1. And that basically takes care of our movement. So every update, our sensor will give information. Our network will give us an output. So we'll feed the information forward. We'll get outputs, and then we'll give those outputs to the fish moving controller. So the thing that moves the fish, and then the fish will move. It's actually pretty cool. So now that that's done, let's see if all errors have been finished and taken care of. Yep, everything is taken care of. Let's look at the fish now. So for input nodes, when we I believe we have 2, right? Because we only have 2 rays, but I want 3. So let's fix that. Let's go back to our input sensors. We have the we copied it once. Let's copy this line over again. And now instead of right, we say left. And that way we get a forward left direction, a forward right direction, and a forward direction. 3 rays being cast from the fish. Let's go back. I believe for left, we do like negative right. But I am not sure. Right? We'll go minus right. So instead of doing plus transform to left, do transform to forward minus transform to right. And let's see what happens. Alright, so that's set up. We have 3 input nodes, 2 output nodes, and we have no hidden nodes for now. And we have errors. Nice, nice. We have errors in our feed forward loop. Specifically line 163 in the neat network. Object reference 163. 63. Now we're going to be on the hunting side of this, the error hunting. So it seems that output connections was never set. The output connections should be set right here. So when we create the network, we're going to put a print right here. Oh, we can't actually print because we don't have... Okay, we'll do a debug.log. And let's see if we get a hello. Yeah. So we get hi right there. So we know that our such an interesting thing. We know that our initializing is happening. Our initialization of the genome happens, and then we create network. So the only thing I can come to think of is when we do for each connection con, there is no connection created yet. Like when we do connection new con and we do connections.add, for some reason we do not have a connection list, but this is getting created. Let's go back to the error, read more carefully. Line 31. Nice. Fish controller 31. So when we call the feed forward network, the initialization of the network works, but during the feed forward loop, something goes wrong. And we know what goes wrong during the feed forward loop. It gets stuck on the connections. So the feed forward loop. At 106. So feed forward network. Then feed forward value. So feed forward value is the error in the edges. Let's go see. And it's that. Oh, I know exactly what it is. Alright, so let's go down to the node. And basically, first of all, the error lets you know, before we get into what the error is, the error lets you know exactly where it is. So it says feed forward network, and then it says feed forward value. Feed forward network is the loop that calls feed forward value for the input and the hidden nodes. And we get a object reference not set to an instance of the object. That error is usually because something is not being initialized, right? So what are we not initializing in our node? It is the list that we created for the input nodes and the output nodes. All right, cool debugging. So right here, when we initialize the node, we set the ID, but now we also need to create the list. And now the input and the output connections are going to be initialized, and therefore we won't get the not set to an instance of a reference object. I mean, not set to an instance of the not set to an instance of an object error. There we go. We won't get that anymore, hopefully. It's early in the morning and I haven't slept, so apologies again. All right, so we get no errors, and everything is perfect. But we get no movement either. Why is that? We can't move anymore with this either because our input is being guided from the feed forward network. So why isn't this moving at all? Because our network in the genome is creating nodes, but we have no edges being created. So there's no connection between the nodes. So when a feed forward does happen, there's no edges. Right? No information can move. Therefore, the output value of the output node will always be 0. Okay? But interestingly enough, we can manually add connections and then we can try to get movement on the specific nodes that we want. So we know that the vertical node is the first output, the turning node is the second output, so we can create connections to the first node to try to get forward or backward movement. And we also know that the positive weights will get us forward movements, so we could give the connection a positive weight, and we should get some type of movement, hopefully forward. Alright, but right now, do not worry, everything is looking perfect. This is exactly where we should be. Alright, so now that that's done, let's manually add an edge to our genome. And we do that in our network, right? I believe in one of the previous videos I said we can add edge connections in the initialization of the genome, right? Specifically right here. So right here we will come in and do a connection gene new con gene 1 equals new connection gene, and now we have to pass it what input and output nodes we want. We want it connecting from 0 to, so we have 3 input nodes, right? 0, 1, and 2. And then we have 2 output nodes and no hidden nodes. So we want from 0 to 0 to 3. Okay. And then, well, I'm not done. I believe it was 0. It was the input node, output node, the weight, which will be 1F, and the active, which is going to be a bool for true. That should be everything for that. And now we add that to the connection genes. The new con genes dot add new on gene 1, and then that gets initialized into our network, into our genome right here, which then gets built right here. Our network, specifically our edges, get created right here, right? So we have our nodes, we have our edges. Let me comment creation of network structure nodes. Edges. And then when we have the when we set the output connections and input connections, we're gonna call this node neighbors. Alright. We got some comments in there. The initial, we got the edge created. Now let's see how this edge does. Let's see how this edge does in movement. However, one problem, I didn't see any raycast. So I don't know if the raycast is working properly. So we're going to see that as well. Let's first make sure everything is working properly. Type connection gene is missing connection gene. What? Oh, con gene. See, this is, there we go. Next. What error? What? I really do that? I did. Sorry about that, guys. Okay, second error down. Next. Yes. The innovation number for each gene. Okay. So right here we have to pass 0. We have to have the input node, the output node, the weight, whether the gene is active or not, and then also the innov number, which is going to be 0 because this is the first innovation. So each as more gene. So the whole reason why we don't have edges to begin with is because our training should take care of creation of edges. Right now, we're just creating edges to show that our network does cause movement, and it is acting how it should, with small number of edges. But in the future, our training should be adding edges. So we start off with no edges and no hidden nodes, and then our training will add hidden nodes. See, over here we have the hidden node loop. However, the hidden nodes are still set to 0 because training should give us hidden nodes. All right. Sorry, I had to stretch. All right, awesome. We get forward movement exactly as expected. So now let's see why that is happening. Okay, this is a great moment, guys. This is the moment where our we know that the structure of the neural network is working, and we know that the feed forward loop is working exactly how it was supposed to be working. And now let's see if we get the raycast properly. That is strange. I'm not seeing any lines. That is strange. All right. So before we do start with the before we do start with debugging, because I do not see any lines being casted. There should be white lines that indicate where the raycast is shooting. Let's make sure our walls are actually tagged. So let's go into our wall, and yep, they're not tagged. So we go into our walls and we go to tags, and we have to add a tag. We have already the fish tag. Now we add a new tag. Call that wall. And now we go back and set each of the walls to be tagged as wall. Alright, so now all the walls are tagged. And the reason why it's important, please make sure that this name, wall, the way you spell it, lines up accordingly with your the if statement in your raycast, right? You see how I have if to hit dot transform that tag equals wall. I guess I didn't explain this, but every Unity object has transforms have tags, right? And the tags we can define what they are. So usually it's undefined, but since we want this to be specific, we want different objects to be sensed, we add the tag for wall, right? And then for fish, we have the tag for fish. So, and then for, let's say in the future, if we want to have food or enemies, we add tags for food and we add tags for enemies. And then this is how we add, this is how our sensors are going to differentiate what different objects are, basically. So please make sure that the tag name is matching right here. Otherwise, the sensor won't see it. And that is why hopefully why we weren't seeing lines. Let's see how this goes. Nope, no lines, it seems. I am curious as to why. So the network is working. It seems that it is getting input that is constantly being sent as a positive value. So it's not getting 0. Let me go to the fish control. Let me go to the network controller, or the neat network. And then where we created the edge right here, let's change the weight to be 0. So anything that multiplies by that will 0 out, and then therefore we won't get any movement again. And let's hope that's working with no movement. Yep, no movement at all. Perfect. Now let's see what is happening. Where is our rays being casted? Because there should be some rays. Let's move this closer. Move this closer. Please be ready to control Z at any time. And there it is. Awesome. So we are having rays being casted, as you can see. But they're just casted in the wrong direction. They're being casted, actually, in the proper direction. They're being casted forward, right, towards the background. We don't want them casted forward towards the background. So let me control Z back to where, everything was. And let's fix the bug. So let's go back to the code. And now we'll scroll down to where let's go to fish controller, and where our raycast are, instead of the forward, we will go up. And now before starting, I want to make sure that up actually exists. So let me see if there's any errors. Nope, because sometimes the directions kind of confuse me, because like you guys saw, right exists but left doesn't. So they pick one and then you have the opposite of the other to get the other. So right should still be fine, right and left, but just we have to change where it says forward. So transform to forward over here, and over here. That should be up, and then that should work. And there we go. That's perfect. So you guys can see that the ray is being casted in the upward direction. If we scroll this down, we see the 3 rays being casted in the upward direction, and up for us is forward because we're in 2D. Okay, when we look at this in 2 dimensions right here, we can see that this is the forward right here. And when vertical, when our neural network gives us the value of 1, it will move forward, right? So upward. And if we turn, this will turn with us. Alright, so our array is working. Now let's add a couple of different edges to see how the edges are affecting our movement. And we will actually add random weights. So let's go back to our fish controller, and let's go to our neat network. Scroll up to where we had the edge being created, the connection gene edge. And right here, we're going to do random.range. And we're going to go from -1f to 1f. Right? And then we're going to copy this twice. Change the names. And we can change the connection as well. We will do a random.range between 0 and 2. I believe that, I don't know if range is inclusive. One second, I'm just searching it up real quick. Yeah. I also sometimes just quickly, if it's something really quick I can search up, I just look on my phone. Okay, that'll be 0. So this will return a value between 0 and 1. So if we go 3, it'll be 0 and 2. And then that's how many input nodes we have. Our input node values are between 0 and 2. And then if we do here, we'll go between 0 and 5, which gives us 3 and 4. All right. So, and then we just have to implement the innovation number manually. And okay, let's see how this reacts. Now, again, this is us manually creating edges to see how our network is handling it. Oh, I changed this to 2. Excuse me. Excuse me again. Third time, excuse me. And now that we have our connection genes set up, we can press play. And we see that kind of more organic movement. We see our network moving right here, and it's moving backwards, but it's moving. So I actually want to see what happens if it only moves forward. So let's pause it. We're going to go back to this. I want to make sure that we are moving on the positive. When we move forward, our direction is going the right way. We'll Yep, perfect. See, we're always moving. We're moving forward now that we have no negative values, which is exactly what we want to see. Our network is set up. Our feed forward loop is set up. Things are looking good. I guess, folks, now it's time to get to the training. Now it's time to get to the real neat part of everything, which is setting up the expansion of the search space and the expansion of the network, and allow the network to forever grow. Right? At this point, we have everything we need to create a normal neural network. If you guys don't want to create a neat network, you guys can basically up the hidden node values and create a loop to create the edges that you want, right? You guys can create a loop to make sure that all the previous layers connect to the next layers and that stuff. You have the structure that you need. And for any neural network, the basic structure that you need is a class for the node, class for the edges, and class for the overall network that holds the nodes and the edges, right? This is how most graph theory structures are created, and neural network, even though it's not a real world network, it is still like a graph theory network. So yeah, now let's move on to the training part of this. I hope you guys stuck through it so far. This is a big moment because we're actually getting organic movement finally. Let's just show a little more organic movement, because I love seeing, things that behave in ways that you wouldn't expect. Having programs usually just do what you want them to do. The beautiful part about neural networks is you'll never really be able to predict what's going to happen. Look at this. This is beautiful chaos. And that's what we try to create. Alright, guys. See you guys in the next one. Peace.